Hi everyone, welcome back to some more 3D printing. I'm Agustin Flawalistic, and today I'm going to show you how well this printer works upside down. I'm now testing the Trinus by Kodama, a sort of modular 3D printer. When I got it, it surprised me how rigid the structure was. All axes are driven by lead screws and are really rigid. All the same module works on X, Y and Z axis. All the printer axes are screwed to this thick metal part, which has some holes. When I saw it, I saw a great opportunity to do some experiments with this printer. I have this hook in my ceiling, just on top of where I work, and I decided to see how well the Trinus performed hanging upside down with this blue rope. Before getting into this experiment, I want to mention one thing. Angus from Maker's Muse did a video some time ago using a 3D printer upside down also. He put the printer upside down, holding it with two shelves, if I remember correctly, and the printer was completely horizontal and it didn't shake like this. Well, in my case, as this is an experiment to test this printer, I decided to use a rope instead of two shelves, as I want the printer to shake as much as it wants. I want to see if this affects the printing process, showing more ringing or other artifacts. I've left a link in the description to Maker's Muse video and I recommend you to check it. Now, going back to this experiment, the first thing I did was to print two samples with the printer on its normal position, the horizontal one, and I printed the exact same G-code again with the printer upside down, well, here in the air. The first sample is this overhang test, and even though I didn't use the right settings, I got a pretty decent result with the printer on its normal position. However, the thing I didn't expect was to get the exact same results when printing upside down. To be honest, it was really disappointing not finding any changes between these two prints. It's ridiculous, right? The second test was slightly different. Printing a test model such as a benchy is usually very good. It helps when setting everything up, but one doesn't print just benches in real life, so I did this fast design on Fusion 360 in some minutes. It's supposed to be me, but it clearly isn't. The nose wasn't big enough. Again, I printed this model with the printer on its normal position and also upside down. Again, both prints look the same and they have the same print quality. The last test was pretty simple. I just printed a calibration cube / tower, and this time I printed both upside down. The difference is that one of them was printed while I rocked the printer, moving it with my hand, and the other one was staying still. I guess that a more violent movement would make a great difference, but I got the exact same results. So again, it was really disappointing. So there are two main conclusions after this small experiment. The first one, when printing with PLA, because this experiment was made printing only with PLA, on an FDM 3D printer, gravity doesn't seem to affect very much the printing results. And two, the Trinus by Kodama has a very good build quality, and I'm really surprised. I don't really recommend any of you to test this printer with this experiment. It's really good, but it can be dangerous. Also, depending on the printer and its structure, you may not be able to perform these experiments. For example, a Prusa i3 will suffer a lot with this test, and enclosed printers don't usually have holes to insert a rope. It just looks like the Trinus was designed for this specific test. If you have any questions about this experiment, use the comment section below. Also, don't forget to like this video, subscribe to this channel and check my Patreon page. And also, huge thanks to all my subscribers for making this irresponsible project possible. I hope you enjoyed with this video and see you next time.